Hello all. In this session I'll be teaching you how to construct different problem on plane scale, how to construct the scales and all. In the previous session of scales I have discussed the complete introduction followed by some problems based on plane scales. In extension to that, a few more problems I would like to discuss based on few conversions. Before moving on, let me write the order just to give you a proper understanding of units, centimeters, decameters and kilometers. This is what we have seen from our beginning or introductory lecture about all the different unit conversions. So now let me take one simple example to brief about a plane scale problem. First problem on plane scale, let me give some given data. RF is equal to, construct a scale of maybe RF is equal to, in the previous session we have taken 1 is to some 5. Now let me take RF is 1.5 centimeter is equal to 1 decimeter. Let me clear this and draw. 1.5 centimeter is equal to 1 decimeter. As I told you in the introductory part of scales, that scales and RF both are almost the same, there won't be any difference. So the ratio can also be given in this way: 1.5 centimeter is equal to 1 decimeter. Now if this is the case, then we need to find the RF first, then followed by maximum length or measure up to distance will also be given. So I call it as a read up to a distance of 1 meter and show on it a length of 6 decimeters, or I can say 0.6 meters. Length of, mark a distance of 0.6 meters. Now let us say this is a complete given data. RF is equal to 1.5 centimeter is equal to 1 decimeter. Read up to a distance of 1 meter and mark a distance of 0.6 meters. Now let us see one by one. So I'll change the colors and write RF. I'm trying to calculate RF now. RF is equal to, already given it is 1.5 centimeter by 1 decimeter. So 1.5 centimeter by 1 decimeter. I like to write something like this. 1 decimeter is equal to how many centimeter? This we would like to see. So 10. For every 1 increment, I'm going to increase 1 0. Just for your proper understanding. Okay, let me say 1.5 by 1 into, I'll say 10, where according to our conversions I'll say 1 decimeter is equal to 10 centimeters. If that is the case, multiplied by 10, that is equal to, so I'll say I'll convert to like 1.5 by 10, 1.5 by 10. So 1.5, I just try to get the round figure, which is 3. Okay, 2 times of whatever the number I have, 1.5, because I can't take RF value in fractions with a decimal point. So I say 3, I just double this number. By 10, I just double this number also. More or less, I mean, you are going to get the same result. There won't be any change. So RF is equal to 3 by 20. So maximum length, what is the maximum length or read up to distance given? 1 meter. Read up to distance is 1 meter. So here 1 meter I have a maximum distance. I'll calculate something like this. 1 meter is equal to 10 decimeters and 100 centimeters. So what I do here is 1 meter is equal to 10 decimeters. So decimeters can't be measured with the scale what I am using. Okay. Scale can measure millimeters and centimeters. So what I'll try to do, I'll try to again convert that decimeters also into centimeters. That I do, okay, in my next conversion. Because here if it is 1 meter, that 1 meter means that measure up to distance, length of the scale I need to calculate. When I draw the length of the line, that line has to be divided into number of segments. So I can't divide that into 1 meter. So what I try to do, that also I'll try to divide into number of decimals, which is number of divisions, which is 10 decimeters. So now when I have these two, I can easily find length of the scale. Length of scale is equal to RF. What is RF? 3 by 20 multiplied by whatever the maximum distance we have calculated, which is 10 decimeters. So again what I do, 1 is already given, 1 meter multiplied by 10. If I'll say 10, it will come to decimeters, if I'll say 100, it will convert to 100, centimeters. That meter is converted to centimeters. If this is the case, then I calculate that is equal to 300 upon 20. I'm going to get 15 centimeters. Now I need to draw a length of 15 centimeters, which I can measure with the scale available. So let me draw a line of 15 centimeter. Let us say this is a line of 15 centimeter. Then what should be the width of the scale? When it comes to a plane scale, the width should be 1.5 centimeter or 1 centimeter. 1.5 centimeter, then again one more line parallel to the baseline, and I'm closing it. Done. Now I need to divide this into number of parts. How many number of parts? N number of parts. How many number? That is more important now. So here the length of the line that is drawn on the drawing sheet is 15 centimeters, which is calculated. Length to be shown is 0.6 meters. That should be shown on the scale. So what I supposed to do now? I need to divide that into number of divisions. I try to divide this complete length, which is in meters, into 10 parts, because maximum distance is 1 meter. So 1 meter is equal to 10 decimeters. Next subunit I have considered. So 10 divisions I'll try to make it. Again, maybe this is first division, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 divisions I made. For every division I try to draw a vertical 2, 3, 5. Conventionally I am representing it. So when you use a drafter, you get a clear picture of it. As of now I am working on a pen tab, so you have to adjust few things. Okay, so now I just try to write down the divisions, third, fourth, fifth division, similarly the other. Okay, the first division, now this is a meter scale, so I have to represent on this, I have to represent two things. Okay, below divisions, next subunits of meters is decimeter and centimeter. I'll try to show both. This side I call it as deci, DECI, and this side I am calling it as centimeter scale. In between I'll write the RF value, whatever is given, 1 by or 3 by 20. Okay, till here it is fine. Now I need to divide this also into subdivision. 1 decimeter is equal to 10 centimeters. So I'll make a mark of 5. From here I'm measuring 1, 2, 3, 4, 5, 6, 7, 8, 9, 10th division is 10 again. So I'll try to draw a line. Okay, this is how we represent. Now on this scale I can measure any distance related to decimeters and centimeter. Now the question, in the question it is given as 0.6 meters I need to measure. 0.6 meters has to be measured. How to measure 0.6? And again I can call that 0.6 as what? 6 decimeters. If it is 6 decimeters, one leg of the dimension line, let me change the color and show you, on the 6, one leg on 6 and one more on 0. This is how I'll try to represent it. Okay, then place an arrow. The ratio should be 1:3. This is how much? 6 decimeters. This is how we need to represent. If it is 6.2, take it. If it is 7.5, then that is also easy. Now this is 7 and this is 5. So 7 decimeters, an arrow, and 0.5 centimeters. I'll change the color and write 7.5 decimeters. This is how I can represent it. So I have constructed a scale with the help of the given data where I can measure 2 units in a plane scale. This is a plane scale. A plane scale can measure up to 2 units up to 1 decimal point. This is what it means. Alright. So this is how a construction has to be made, and this width is 1.5 centimeter. Alright. I hope I'm clear. Let us take one more problem on plane scale. Yes, I want to clear the thing and I come up with a new problem. Let me take one more problem. Draw the scale of 1:50. RF is equal to 1 by 50, showing meters and decimeters, and to measure up to 8 meters. This is what given. And where on the same on the scale I need to measure meters and decimeters. Meters and decimeters both has to be measured. So firstly we need to calculate. RF is directly given, so length of the scale has to be calculated. LOA, length of scale, is equal to RF, which is 1 by 50 multiplied by 8 meters are given. 8. So again, if you don't remember, Try to remember this, then it becomes easy for you to understand. I'm converting meters to centimeters. Okay. Meters to centimeter, which is multiplied by 100. So I'm multiplying with 100. Okay. Because whatever the number of steps you're moving up, that many number of zeros we need to take or consider. Okay. So this 8 meters, one more point, this 8 meters is number of parts of the scale. This maximum distance stands as what? Number of parts of scale, whatever the scale length we calculate. So after calculation, what we are going to get? 800 divided by 50. 16 centimeters we are going to get. Okay. So I need to draw a length of the line as 16 centimeters. Let us take this as 16 centimeter, then a width of 1.5 centimeter, then one more parallel line to that, then one more. I'm closing it. Now how many divisions I need to make? 8 parts, clearly mentioned. Now that I can make easily. Okay. So either you can divide this into 8, whatever the number you get accordingly. Try to make divisions by using a compass, or old method is already available. What is that old system method? Draw any acute angle of infinite distance, then try to divide this into 8 parts. 1, 2, 3, 4, 5, 6, 7 and somewhere 8. Alright. And join the 8th division with the end point, accordingly draw the parallel lines. That is what we have seen. No? Now I'll directly make it. This is first division. This is the first division. Second, third, fourth, fifth, 7 and 8. Alright. At every intersection, I'll try to draw a straight vertical. I'm dividing the complete length of the scale into 8 parts, because why only 8 means the maximum distance given is, or measure up to distance given is 8 meters. That is why I'm doing 1, 2, 3, 4, 5, 6, 7, 8 parts. So the first 0, first, second, third, fourth, fifth, sixth and seventh. So we can call this as first division also. You might have a doubt like why we are starting with 0 means. You can start with 1 also. Okay. If you start with 1, only main scale units can be read on the scale, whatever constructed. Okay. But if I want to read a distance of 5.4, or if I want to mark a distance of 5.4 meters, which is not possible, because if I start from here, first division 1, 2, 3, then I can measure only 5 meters or 6 meters or 1 meter or 2 meters are possible. But this decimal point unit can't be, or it is not possible to measure on the scale. That is the reason I'm starting with 0. I'm calling the first division as subdivisions of the main divisions or subunits of the main units. So I make number of main subdivisions. Here is, I'll try to make 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. That is what I do. And at every division try to take a vertical line. Okay, vertical line. So like this is one vertical. Likewise, every division you have to construct it. If I make it, it becomes clumsy. That is the reason I'm not making it. Again, if you want to divide this into 10 parts, again take an acute angle, then join the last point with the end point, try to draw the parallel lines, you get the divisions. That is also possible. That is one way. Now this is how we need to construct a line. Now after this, finally let me give the labeling or naming of it. This is the main scale, which is meters, METER, meter scale, underline it. Then the subdivision, 1 meter is equal to 10 decimeters. So this DECMET, decimeter scale, underline it. In between write RF, which is equal to whatever is given to you in the question, 1 by 50. Now you can mark whatever is required. For example, 5.4 meters, 5 meters and 0.4 somewhere here. Yeah, this is the line, no? 0.4 meters, something like this. And place one arrow. 5 meters, 0.4 decimeter. This is how I can read 2 dimensions or 2 units, meters and decimeters, on the same scale. Alright. So I hope you understand this particular concept. Again, I'll take one simple problem, one more problem I would like to solve here. Simple problem. Take the data, some data, I'll consider some. Let me keep this conversions for the upcoming problem and we solve it. Okay. Let me take directly some given data or direct problem. I'll try to take RF is equal to 3.2 centimeter by 4 meter. This is a problem. already existing. So a 3.2 centimeter long line represents a length of 4 meters. And extend this line to measure length up to 25 meters. Measure length up to 25 meters means maximum length is 25 meters given. And show on it units of meters and 5 meters. Show the length of 17 meters on this line. Show the length, nothing but mark a length of 17 meters. As I said in the beginning, in my first lecture, like plane scale can measure up to 2 units. First point, this is also plane scale, up to 2 units, that is fine. And one more point is up to 1 decimal point. This is what I said, no? And those 2 units could be same or different. For this case, 2 units are same. What is that? He is asking us to mark 17 meters. Okay. We'll see step by step how, because you don't have any sub units. So we'll see one by one. Let us calculate RF first. RF is equal to, let me change the color and show you. RF is equal to 3.2 centimeter. Directly I have not written the question. Directly I took the what you call data from the question by 4 meters. This is what given. I need to convert one by one. That is equal to 3.2 centimeter by 400. If I calculate, finally what I am going to get is 1 by 125. RF is 1 by 125. Maximum length given is 25. If the maximum length given is 25, now we need to divide the length of the scale into 25 parts. So we'll see the tricky point here. Length of the scale I am calculating, which is RF multiplied by maximum length is what? It is 25 meters. So I want to convert this 25 to centimeters, that is equal to 100. So if it is multiplied by this, what you are going to get? Finally, you are going to get 20 centimeters. Length of the scale is 20 centimeters, where here for this 1 meter is equal to 100 centimeters. Alright, this is how. So by considering 20 centimeters, I'll draw a line. Okay, let me draw a line of 20 centimeters. Then I'm closing it with 1.5 centimeter height with one more line and closing it. Now how many parts? As I said from my basic discussion, whatever the maximum distance given, that many parts we are supposed to make, but the maximum distance is 25. If I keep on dividing this into 25 parts, the part distance becomes very small. That is first point, and the sketch becomes very lengthy. So what I'll try to do, which is not a possible task, up to 15, up to 15 divisions there is a possibility, but after 15 divisions what you're supposed to do is the division distance or the units length should be, naming should be changed completely. How we'll try to change? Let us have a look at it. Okay. So the length of the line that is drawn on the sheet is 20 centimeters, which is calculated from length of the scale. That is fine. This subscale is to be divided into 5 parts. I'll try to divide this complete length of 20 into 5 parts, 5 divisions. Why 5 parts? Each part will measure 5 meters. So here what I'll try to do, simply this is first part, second part, third, 4 and 5. Why I did this, I give my explanation. This is one more, the third one, 4 and 5. Again the same old concept, first division as 0th one, 1, 2, 3 and 4. But what I'll try to do is, as I have divided this into parts, I say each division 1, 2, 3, 4, 5. Each division I'm calling it as 5 meters division, 5 meters. So here what I'll try to do, I'll try to change this to what? 5, 10, 15. Only naming sake I'm trying to change this to 20. So 5 meters, 5, 10, 15, 20. Ultimately it should read up to 25 meters. Ultimately the scale should read up to 25 meters. So I'm changing the naming. After this, the scale will read meters, given underline. Then as I said, it is a plane scale, but it will read up to 2 units. Both the units are same. Okay, this is subdivision is what? Read up to 5 meters. Why I'm writing this? Because it is given in the question is a 3.2 centimeter long line represents a length of 4 meters. Extend this line to measure length up to 25 meters. Maximum distance is given. And show on it units of meters and 5 meters. Show on it units of meters and 5 meters. They have given. That is the reason we are representing it on the scale. So write RF. If that is not given, then no need to worry about whatever we have calculated. Directly you can take the subdivisions of the next decimeters only. But in the question they have represented as show on it units of meters and 5 meters. Full stop. Show the length of 17 meters on this line that we need to mark. So what I supposed to do now? This subdivision I need to make it to 5 parts. Okay. Let us take this as first part, second, third, 4 and 5. So for every part I'll drag a line. This is first, second, then the third one, final one. Alright. 0, then it's 1, 2, 3, 4 and 5. Okay, this is what I made. Now they are asking me to mark a distance of 17 meters on it. 17 means what? This is 15 plus 2 will give you 17 meters. Okay, for that I just change the color and show you. This is one leg on 15, one leg on 2. So this is a different problem from when you compare with other problems which I have constructed before, because the difference in sense the same plane scale is reading both the units. I mean same units, two units are same. What are those? Meters only. The main scale will read meters, subscale will also read meters. What is this now? 17 meters. This is how plane scale can be constructed. This is about how to construct different ways of constructing plane scales. Alright, this is how we can do. Now the case might be different. Now whatever the unit we are measuring is in centimeters and millimeters. For example, few problems are there. They might give you problems based on, let me show you, let me shift this. The problems might be different. Like for example, if the problem is given in millimeters or centimeters, decimeters or meters, decameters or hectometers or kilometers, then we are trying to convert everything in centimeters as we can measure centimeters with our scale, whatever the scale we are using. That is the reason we are converting everything to centimeters, finding the length of the scale and constructing it. That is fine. But there are few cases where the problem might be given in inches also. Inch, feet or foot and maybe yards. If this is the case, we need to know the conversions. Okay. Basic conversion we know. 1 inch, okay, 1 feet is equal to 12 inches. This 1 feet is equal to 12 inches. That we know. We should know one more thing, that 1 yard is equal to how many feet. This is important. 1 yard is equal to, if this is the case, 1 yard is equal to how many inches, that we should calculate. This multiplied by 12 multiplied by 3 will give you 36 inches. If you know this in conversion, then problems on it can also be easily solved. Let us take one simple problem in plane only, and let me solve it. Let me directly take the given data. I'll consider given data as, let me take 1.5 inch is equal to 1 feet, which is RF given, and measure up to distance or maximum distance as 4 feet is considered. Now we need to calculate RF first. We need to take everything into one unit so that we can cut and it becomes unitless. Accordingly we can find the length of the scale. Okay. This 1.5 inch is what? Length of the scale. Length of scale is 1.5. This is actual length. That is what for the formula is, no? So RF is equal to, let me calculate here. RF is equal to 1.5 inch. I want to convert. Now the problem might be given. This is 1 centimeter, 2 centimeter, 3 centimeter. In between you have subdivisions. This will read millimeters. The other side if you'll see, it will read inches. 1 inch, 2 inch, 3 inch likewise. That way it will help you out. So if it is in foot, feet or yard or inches, try to convert everything into inches only. Then the problem becomes easy. Okay. So I'm trying to calculate this RF 1.5 by 1 feet. I'm trying to convert again, which is equal to 1.5 by 1 feet is equal to 12 inches. No, I'll try to take it as 12. If I calculate, I'm going to get 1 by 8. RF is equal to 1 by 8. Once the RF is known, length of the scale is equal to 1 by 8 multiplied by whatever the maximum 4 feet is given. Again multiplied by 12 because 1 feet is equal to 12 inches. So you are going to get how much? 6 inch. Now inch scale is with you. Directly draw a line of 6 inches. Then a width of 1.5 centimeter. Then close it. Now how many parts I need to make? That is more important. Maximum is what? 4. So divide this into 4 parts. Maybe this is your first part, second part, third and fourth. I have more distance, so this is my first part, second, third and fourth. Let me draw a line. Every division, first division, second division, third and fourth. Again the same old discussion, 0, 1, 2, 3. Each one division will read 1 feet. So it is maximum distance is feet. What I can read now? Feet and this one. So next subunit can be read. So I can easily draw the scale and I can write this as what? Feet underline and inch. RF is equal to 1 by 8 after calculation, whatever. Okay. But the subdivision 1 feet is equal to 12 inches. So this subdivision has to be divided to what? Let me change the color and show you. 12 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12th part. This is 12th part. This line vertical. Likewise, you have to give the numbering followed by, for each division you have to draw a vertical. That is also important. Draw one vertical. Likewise, draw all the verticals accordingly. Plan. Now, if somebody asks you, or in the same question, a mark is given. Mark a distance of 2.3 feet. So one leg will be on 2, one leg will be on third division. Accordingly, draw the dimension line. This is what we'll try to do. So ultimately, one thing is important: whenever units are given in any of this order, try to convert into centimeters. If the units are given in the question as feet, foot, yard or inch, try to convert into inches. Then your problem, construction, everything remains same. And other than that, RF has to be calculated. Everything has to be converted to 1 unit so that it becomes unitless as it is a ratio. Then find the length of the scale. Accordingly, the length of the scale becomes the length of the drawing. Accordingly, you can make the construction. Okay, this is all about a plane scale and its conversions and how to mark the representations, everything. This is all for the session. If you have any queries related or anything other than this, if you want me to explain, you can comment in the box given below. Thank you.